So hello everyone to my talk Real-Time LuaTeX Recompiling Large Documents in 1 millisecond. I'm Clemens Load and I'm the founder of Load Publishing, and Conor Craig is the editor. The big question is, why yet another LaTeX editor? So the market is filled with LaTeX editors, but in my special case, so Load Publishing's primary business is typesetting and proceedings, and we constantly have projects in LaTeX with more than 800 pages. Recently also proceedings with thousands of pages, and working with the common LaTeX editors, including Overleaf, etc. It really takes a long time toward the end of a project, polishing, really clearing up the white space in a project. And this led me to developing LaTeX templates first for books and proceedings. But that got me only that far. There's also no InDesign-like program for LaTeX book typesetting. It's really stuck in this batch compiling of text files. Artificial intelligence opened some doors in a few recent years to get a better understanding of deep LaTeX internals that maybe just a handful of people know, at least concentrated in the world. And also because of my background in operations research and evolutionary algorithms, and some discussions on Reddit and some back and forth about the upcoming Typest editor, like basically one of the rivals of LaTeX these days. And because of my background in building user interfaces for optimization problems, I decided, okay, hey, maybe I give it a try. And really, maybe the last actual motivator last year, I questioned all my life choices when Overleaf moved the chat button. So I really had one extra click each time I discussed open issues with my editor. So eventually I thought, okay, I can do better. I can build something that is really focused on my use case. So reduced recompilation times for very large projects. This speed versus quality trade-off I discussed in my last book last year, published this year. Back then I still thought, okay, we have the advanced typography algorithms in LaTeX, and that is only possible if you really compile the entire document separately in a separate compilation phase. And you have, on the other hand, Word, which is real-time, but it uses simpler algorithms. So I assume there's a trade-off between speed and quality. From like UX design, human interaction with the computer, we know that like anything under 200 or 100 milliseconds feels instantaneous. Better probably like below 20 milliseconds to really get that like 60 hertz refresh rate. Up to 1 second, well, there's still an uninterrupted flow of work, but at like 10 seconds, so if you move your mouse and it takes 5 seconds or 10 seconds, like the program is lost. So you lose attention, you get frustrated. Anything like beyond 2 minutes, it's okay again if the program tells you it, because you say, okay, I'll grab a coffee while it's compiling. And what is missing is, of course, like a high quality software that stays below that 100 milliseconds threshold. Prior attempts to bridge this gap, it's ongoing since at least 1995. So sorry if I missed a few items here. So that's just what I found or what I knew. So it's 1995 with LIX. It has a structured preview, but it still needs like the batch LaTeX for the final output. We have in 1999 the GNU Tech Max. It's a true what you see is what you get, but it also delivers its own engine, so it's not really tech compatible. In 2002, 2003, depends on where you put the year. You have Bacoma Tech. It is more like also what you see is what you get editor, but again it has a modified engine, so it's not like vanilla tech. In 2012, people began with software as a service. Back then, Share LaTeX and Write LaTeX, and that was combined later in Overleaf. There you have all the standard engines, all the standard LaTeX, and it's fully compatible. And their approach was, okay, let's focus on collaborative editing and let's focus on the whole server landscape. So you don't have to care about installing LaTeX or switching different versions. You have the compatibility, but of course the actual compilation still runs in one run and relatively slow. 2014, you have KTech. It's in the browser, JavaScript based. You have fast math rendering, but it's not really a full typesetting system. So it's similar to Tech, but you can't like run any Tech file. Plus, it's not 100% pixel perfect compared to a clean batch LaTeX run. 2019 with Swift LaTeX and BusyTech, that you have like WebAssembly solutions. So you solve the issue of servers that you need, separate servers you need. You run the whole thing on the user side, but of course the user still has to download the WebAssembly, and you still have to do full compilation runs. In 2023, you have TechPresso and Tectonic. It's a modified CTEX engine with a fork. So you take snapshots, so you don't have to recompile everything that was unchanged until the paragraph or chapter you were editing. And of course, the limitation is Linux and Mac OS. You can run it with VSL in Linux, in Windows, but of course, it is a limitation. 2023 also start of Typest, incremental compilation with memorization. So you focus on the question, if I change something, what other parts of the document are affected? So you reduce the amount of things you need to recompile. It is not tech compatible, faster than a standard LaTeX compilation. So you don't have like to call LaTeX 3 times and to get all the references right. But as we see later, it does scale ON, meaning larger documents, longer compilation times. I will address this a little bit later. So what I saw in 2024, 2025 is there's a real market gap, sub 100 milliseconds, O1 compilation time with an unmodified LuaTeX engine. So my initial approach was, okay, I know in LaTeX you have include operations. You can use include only. You can cache individual chapters. You can include PDFs, so you don't have to recompile everything. You can cache that. With LaTeX MK, you can check whether files were changed. And this was my first approach. So you can do faster recompilation of larger documents with some caching, but it wasn't really where I wanted to go. And so really the question was, okay, how fast could we theoretically go? Really, if we ignore all constraints, let's see how fast is LuaTeX or LaTeX in general really. So I did some benchmarks for the real technical limit for recompile times. So I measured individual paragraphs of different sizes, over 500 compiles per category, all with like full microtypography, OpenType, shaping, and reached the verdict, okay, short lines, just 0.17 milliseconds on average, long lines 2 milliseconds as a medium, and medium lines 0.7 milliseconds. Obviously, you can here argue, well, a chapter theoretically could contain just one single paragraph over many, many pages. So you always have like no maximum in terms of recompilation time. But really my focus was books. And for books, usually paragraphs are around 4 to 5 lines. So proceeding with 0.7 milliseconds, I thought was a good starting point, like as a lower technical limit. Obviously, those compilation times depend on the CPU. We just use a standard laptop. So in theory, LuaTeX is fast. So there's no like, okay, it's slower than this or that, or it takes a long time. So it is really, really fast, and it can render updates at 60 Hertz or more. Also, of course, I tested, okay, is there like a degradation over time if I recompile 500 times? So it really works here. It stays the same. I did see a few LuaTeX bugs that there were some fonts accumulating due to some rounding errors, but those are fixable, so it's not an issue. So the question is, okay, is this enough? Can we really say LuaTeX recompilation is 1 millisecond or 0.7 milliseconds? First, the Knut+ line breaking algorithm is paragraph local. So it doesn't matter what other paragraphs contain. The paragraph itself, it's limited, and the algorithm applied to it is also limited. Also, editing one paragraph does not change the line breaks in another, obviously, and boundary cases like footnotes, references, also those affect page breaks, but not line breaks. Also, the user obviously edits only one paragraph at a time. There is a case to be made, okay, if multiple people edit the same document, but for my use case, okay, one paragraph at a time. So we can summarize the smallest organizational unit in LaTeX is a paragraph. And only the edited paragraph needs to recompile per keystroke. So if you type something, you don't have to check again the bibliography or the other chapters. You only have to apply the changes to a single paragraph. And this is nothing like revolutionary. It's like Word or InDesign does it. It's like most other editors do it. They just recompile a single paragraph. Still, it sounds simple, and some of you might now be motivated to try it yourself, just recompile a single paragraph, but it soon feels like in Star Trek, the motion picture, where you have like this old technology in the middle and like an entire ecosystem of tools around it. So my approach was to put like a vanilla LuaTeX in the center and put all the wiring around it instead of changing the central core unit. Obviously, LaTeX was never designed for this. It's 50 years old, and 50 years ago, real-time editing complex math equations was not really the focus of it. And with every new package I look at and test, there's always a little bit of fighting going on, especially for algorithms that are actually including like page breaks or something like that. As an additional challenge I put myself was to build like a real client-server model. So networking puts additional latency to the whole thing. Let's look at a demo now, because that's why you're here. Okay, here you see you can drag and drop RUB fix, and you see the same time you're dragging or changing something, the LaTeX data adapts, like left and right, or the sizing, or just moving around. You can also add, obviously, some tables. Here you see writing in real time, the columns column names, nothing special except for the fact that it's real time. We'll add some content so you see how the paragraphs work inside the table. I'll just copy it here from below, just adding a number of cells here. In the output, of course, you see it's not yet a paragraph, so I will adapt this in the header. So now you see, well, it's updating. Now you see a paragraph, or in paragraphs, so with line breaking, 1, 2, 3, and you can in real time adapt the widths of the individual columns or cells. Of course, you can also move it around. Here you see a quick demonstration of the highlighting, so it's also in sync with the text editor, and there's of course a 2-page mode, so you can, like, what you see is what you get, directly type it, so you don't even see LaTeX. That might be good for beginners. There's also like an inspector panel where you can directly adapt the font, and in the LaTeX you see here it's surrounded by a particular style, so similar to, let's say, Webflow, where each style gets an own ID. Here's a very, very long document. I just took one from Archive, and here you can see me just scrolling through it. So it's a lot of equations. They're originally from PDF text, so they don't translate 100%, and the author did some customization, so it's not a 100% conversion, but at least the equations are there and the text is there. So let's scroll through it a little bit, and let's pick, let's say, a random part here, and here let's just type in here, and we can also write here. It's a little bit slower, actually. I'm working on this a little bit, so there are some issues with very, very large documents, but I'm working on it. Previously, I mentioned TIPST and why it is 01. So I ran also a few benchmarks here. The same medium paragraph, 4 to 5 lines with TIPST watch, over 30 edits, and warm up, of course, excluded. So it's just the focus of the compilation for better comparison. And you see, like, with 10 pages, it's super fast. It stays below 20 milliseconds. But as soon as you get like 100, 300, maybe 1,000 pages, you see an increase. And this increase is also reflected in additional versions. That means the architecture of TIPST moves into a different direction, moves more in the direction of features and correctness of the entire compilation, and not in the direction of, okay, let's make it faster, let's make it faster, let's make it faster. My approach was to keep it for all sizes of documents constant. I did some research, like what's behind it. I'm not that deep into the TIPST architecture, but it really is ultimately a design decision. I mean, you can probably change the architecture a little bit of TIPST to make it real time. Also, I'm convinced that eventually I could just replace in my own editor to say, okay, switch between different compilers, switch between LaTeX and TIPST, and you have that as the core unit, and you can then also achieve constant length of each compilation. And from the creator, for the question, okay, could we do like a partial evaluation for huge documents? There's a separate TIPST issue, and at least in 2024, the judgment was, okay, it is not feasible. Ultimately, I think those are different, like, target audiences. For example, TIPST does a lot of batch compilation of many different documents, while my focus is really like a single large document where you add a lot of small edits, especially towards the end, when you move things around, when you edit small things that you don't have to wait each time 2 minutes until you see the result, just because you like moved a little table left or right or increased the width of a figure or image. So my point was really, let's do it like InDesign. I really want to see the final result of my change. One interesting thing or one interesting thought that came up for me while working on it is like this could open a lot of doors in the LaTeX development, because a lot of features like are on the horizon in typesetting, but have not found their places in the LaTeX development. For example, there is no real algorithm to do a float placement over the full book instead of just going page by page. So you can't really have optimal float placement with the current page by page compilation that LaTeX does. Same like optimization, when you have a book and have 2 pages in front of you, you can't do an optimization that the 2 pages look good. So you have to go page by page. Also, there is an option like for similar avoidance to improve like penalties for line starting or ending with the same word. You can apply then river avoidance better if you can recompile. Also possibly like variable font justifications. And in general, I could imagine that all those different parameters like badness, looseness, also you could apply evolutionary algorithms to optimize each page to look good, because you can recompile quickly and see the result and adjust it a little bit, and then after a few seconds maybe, or just partial parts of a second, you have an optimized value for each paragraph or each page. So that I find exciting for future developments in that field. You can get a hands-on demo in the Frankfurt Book Fair, of course in Germany, if you fly over or if you're already attending. I'm at booth F97, hall 4.1. And the focus there is more like on the proceedings side, like really large documents in the proceedings field with thousands of documents, PDFs, etc., and combine that into a LaTeX document. And there you can bring your own tech project, and we try it out. How does it look in real time? How you can edit it in real time, and then just give it a go. Feel free to mention the talk, and then we can chat a little bit. Alternatively, go to texlode, sign up for the waitlist. I'm still figuring out a few things, but it's close to starting a beta test where you can try it out for yourself. So thank you very much. Full details of the benchmarks are available in the preprint. I also have the benchmark scripts for types and for LuaTeX. You can test yourself. And of course, as mentioned, sign up for the waiting list or drop me a line. Thank you very much. And now I'm looking forward to your questions.